Hello students, today we'll start the uh, motion in plane and related to that the scalar, vector, position and displacement vector. First of all, we have to identify the physical quantity. Physical quantity is that quantity which is measurable and it can be expressed in terms of numerical value. And that means you can be, what is your weight? Your weight is 50 kg. That means this is the numerical value, this is the unit. So any physical quantity, it can be expressed in terms of NU. N is the numerical value and U is the unit. So the physical quantity is measurable. And now this physical quantity is classified to one is the scalar, another the vector. Scalar is that quantity which is fully described by its magnitude, no direction, magnitude, only magnitude. And it has magnitude, no direction. For example, you can take that length, mass, time, electric current, temperature. These are the scalar quantity. And vector quantities are those quantities which have their both magnitude and direction. For example, displacement. It has a both magnitude and direction. Velocity is also the magnitude and direction. Force. These are the vector quantities. So vector quantities has both magnitude and direction. And what is the difference between the scalar and vector? Scalar have only magnitude, vector have both magnitude and direction. Scalar change if the magnitude change, but vector can change either magnitude change or direction change or both change. Then the vector will be changed. And scalar, you see simply it is added. That simply 5 plus 5, simple addition, vector addition, simple addition, ordinary algebra addition. But vector has a special addition law, triangle law, parallel law, vector addition, and polygon law. Now, how can represent the vector? Here you see, this is the vector A. A represent an arrow at the head. This is an arrow. Vector is represented by arrow. Here see arrow. This is the initial point, tail, and this is the head. The length of this entire, this is the magnitude, and the directed towards the arrow is the direction. Okay. So magnitude, it is nothing but the length of the vector, which is scalar quantity. Magnitude of vector is a scalar quantity. Okay. Now, position vector and displacement vector. Position. You see, when we plot a graph, then we consider one axis and another axis is one, and one reference point. This is the reference point. If it is x, y, then we move x distance here, y distance. This is the position of a particle. Simply, position vector is also the position of particle expressed in term of position vector. Okay. Here also one reference point is there. We are considering this one is a reference point. Now, if I cap and j cap with the unit vector along x-axis and y-axis, then you see the vector length here will be, this will be I cap x and this will be j cap y. So the length of this is xi cap, this is yj cap. So these vector are equal to xi cap plus yj cap. Now if this angle is theta, then what will the value? Ox equal to r cos theta, and what is oy? O o ox means x, and y, what is y? Y equal to r sin theta. So you should substitute here. So in terms of theta, r theta, polar coordinate, then vector equal to r cos theta I cap plus r sin theta j cap. This is for 2 dimension. And for similarly for 3 dimension, suppose P is the position vector. So what is this? The coordinate is x, y, z. That means you move x direction x, then y direction y this, and z direction z. So what is the if I cap, j cap, and k cap is the unit vector along x, y, z, then this will be xi cap, this will be yj cap, and these length will be zk cap. Then the position vector r will be xi cap plus yj cap plus z k cap. This is in case of 3 dimension. Now move to displacement vector. So displacement vector is nothing but it's a change of the position vector from initial to final. Suppose this is the initial position and this is the final position, OA and OB. Then AB is the displacement vector. It is the initial position object, displacement of the object with respect to the initial position to the final position. So if Ri and Ri be the initial position of vector and Rf is the final position vector, then displacement vector OB equal to Rf minus Ri. So here what is the Ri? Ri equal to xi I cap plus yi j cap. Rf equal to xf I cap, yf j cap. So displacement vector delta r equal to difference of this. You take common I cap, so xf minus xi I cap plus yf minus yi j cap. And then what will be the magnitude of this? This is equal to square of xf I f square plus yf minus yi whole square. Okay, for it is for 2 dimensions. Similarly, for 3 dimension, this is the initial, this is the initial vector, this is the final vector, position vector. So, what is the displacement vector? Displacement vector is the difference between the final position vector, initial position vector. Okay, so if you take the difference between Rf, this is the Rf minus Ri. So Rf that equal to, you take the common I common, then xf minus xi xf minus I cap plus yf minus yi j cap plus zdf minus zi k cap. So what is the magnitude? Magnitude is nothing but the square root of the xf minus xi whole square plus yf minus y whole square plus zdf minus zi whole square. Now we take one example. This is the coordinate of A and B. Then what will the initial vector, final vector, and displacement vector? Now you see initial vector. If I cap, j cap, and k cap the unit vector, then initial vector, what is that? This is the initial point. So initial vector equal to 1 I cap plus 2 j cap plus 3 k cap, and final vector position equal to, final vector equal to 3 I cap here, 3 2 minus 3. So 3 I cap plus 2 j cap minus 3 k cap. Now what is the displacement and the formula? This one the formula. So this is the displacement vector. Take the difference between these, 3 minus 1 I cap, 2 minus 2 j cap, minus 3 minus 3 k cap. So this is the final. Now if we move another, you are taking another example. A bird is flying due west with a distance of 100 meter and then heading due north by a distance of 50 meter and vertical 20 meter. Find the position of the bird relative to initial position. Now here you see, we are considering this is the plane. In this plane, this is the xy, and upward and downward we are considering the z axis. Along x-axis we are considering the unit vector I cap, and along axis mean west to east. Obviously, south to north it is the y-axis, and upward is the z-axis. So this one is the 100 meter means 100 I cap, and here towards north, so it is the towards north the 50 meters, so it is the 50 k cap, and upward is the 20 k cap. So this is the actual position vector. Now if you get the position vector, then what is the displacement with respect to this? This is the square root of the this and this. We are taking, and this is the final result. Okay, thank you.